Today's topic is compound inequalities. Make sure that you know how to solve and graph inequalities in one variable before you tackle this topic. A compound inequality happens when two or more inequalities are joined together, usually by the words and or. Today's compound inequalities will only have two inequalities joined together, and when you see the word and, that will indicate the intersection of the two inequalities, or where the two inequalities overlap. The word or indicates the union of two inequalities, and we're going to include everything from both inequalities at the same time. Let's start with a compound inequality x is greater than 5 or x is less than 0. There are a lot of values that fall into one or the other category, so let's take the time to graph each one. We first graph x is greater than 5, open dot at 5, shaded to the right. Then we separately graph x is less than 0, which involves an open dot at 0 and shading to the left. With the word or involved, everything that's now shaded in blue is part of our solution. We just need values to be in one inequality or the other. It doesn't matter which one. Since there are so many values involved, we generally answer inequalities with a graph, because it would take way too long to list each number in our solution individually. Besides the fact that's impossible because there's an infinite number of solutions. Let's take a look at a different type of compound inequality. When you see an inequality written in this manner, it indicates that there are two inequalities represented. The first inequality is pretty simple to see. The second half of the equation says x is less than 4. The second one, though, is a little more difficult. It comes from the first portion of our inequality. If I were to write that inequality in mirror form or mirror image, it would look like x is greater than negative 3. That's the same as negative 3 is less than x. When I write the two separate inequalities, I need to use the word and. Let's take a look at what that looks like on a number line. Here's the inequality x is greater than negative 3. But I also need to take into consideration that my values need to be less than 4. So if I take what's on my number line already and eliminate all values that are greater than 4, I have my intersection. These are all the values that are both greater than negative 3 and less than positive 4 at the same time. And that's generally what an AND compound inequality will look like. Here we have a third type of compound inequality. It looks very much like the inequality we just had, with one exception. Our variable in the middle section is not isolated. So in this case, we have to solve or isolate our variable just like we would in another type of inequality or equation. But in a compound inequality, instead of just having two sides, a left side and a right side, we have three separate sections where we must perform each operation. To get x by itself in the middle section, we would first subtract 1. And in an equation or inequality, generally we would subtract 1 from both sides. However, since I have 3 sections, I have to subtract 1 3 separate times. When I simplify, 3 minus 1 is 2. In the middle section, I'm just left with a negative 2x, and on the right, 7 minus 1 is 6. Then, to get x by itself, I have to divide by the coefficient of negative 2. And again, I have to divide all 3 sections by my coefficient. This should be setting off a red flag in your head at the moment because we're dividing by a negative coefficient. And don't forget what that means, that we need to invert or flip our inequalities. I'm left with negative 1 is greater than or equal to x, which is also greater than negative 3. If that looks a little funny to you, it probably should, because negative 3 is actually the smaller number. It's okay to say all values in between negative 1 and negative 3, including negative 1, not including negative 3, but since negative 3 is a smaller number, quite often you'll see it flipped. Again, if I write this as a mirror image, I get negative 3 is less than x is less than or equal to negative 1. And if you saw this on, say, a standardized test, that's more likely how it would be written. Here's another compound inequality, this time with the word or. So we're looking for the union of both inequalities at the same time. And we need to solve these inequalities separately. To solve the inequality on the left, we add 5 to both sides, and I get x is greater than negative 2. To solve the inequality on the right, I divide by the coefficient 3 and get x is less than or equal to negative 9. Since we have the word or again, we want to graph both solutions on our number line. We start by graphing x is greater than negative 2. Open dot at negative 2, shaded to the right for the greater than. We also want to graph x is less than or equal to negative 9. The picture, remember, is our solution. Everything shaded in blue is part of our solution now. Sometimes you'll see and compound inequalities written as 2 separate inequalities. To solve the first, we divide by our coefficient of negative 8. Since we're dividing by a negative coefficient, we flip our inequality. In the second inequality, we divide by positive 4. We don't need to flip our inequality that time, and we get k is greater than or equal to negative 6. Since we have the word and, we don't need to combine the two inequalities. It's okay to write it as is. And now on to our graph. I'm first going to graph k is less than 6. Then separately, I'm going to graph k is greater than or equal to negative 6. Since we have the word and involved, and means intersection, we just want the portion of our number line where the two inequalities overlap. Here's our solution. One last inequality, and one to watch out for when you're solving compound inequalities. I have the compound inequality x is less than negative 2 and x is greater than or equal to 1. And if I graph those on a number line, x is less than negative 2 and x is greater than or equal to 1, remember we had the word and. That means the intersection of the two inequalities. Since these don't intersect, we have no solution. So we would write no solution, or we could use the empty set symbol to indicate that there's no solution. Okay, don't forget you can rewind and watch examples again. I hope you have a fantastic day, and I'll see you next time.